Welcome to question 15. Look at this massive chain of signum functions. When students see signum of sin x plus signum of cos x plus signum of tan x plus signum of cot x, all added together, they anticipate a grueling multi-case calculus problem. That is a complete illusion because the main domain excludes the coordinate axis, and this whole problem reduces to a basic high school quadrant rules. So let's think sharp. The signum function only cares about one thing. Is the inside value positive, negative or 0? Since x is not equal to n pi by 2, 0 is completely off the table. Every single term on your screen can only ever output a +1 or a -1. So all we need to do is map this across 4 quadrants using the standard ASTC rule. That is, add sugar to coffee. So let's run through them. In first quadrant, that is quadrant 1, all 4 terms are positive. So fx is equal to 1 plus 1 plus 1 plus 1. That is equal to 4. Now in the second quadrant, only sine is positive. So rest, cos, tan, cot all are negative. So their signum function will yield a -1. So we have fx equal to only 1, then -1, -1, -1. So that gives me -2. In the third quadrant, only tangent and cotangent are positive. That is tan and cot. Whereas sine and cos are negative. So fx will be equal to -1, -1, +1, +1, which gives us 0. And finally in quadrant 4, only cosine is positive. So fx is going to give us -1, +1, -1, -1, repeating our value of -2. So our entire range is just 3 unique integers, -2, 0 and 4. Now the question doesn't ask for the range itself, it asks for the sum of the elements in that range. So adding them up gives us -2 plus 0 plus 4, which is equal to 2. So just like that, for this question, option A is your winner without a single line of heavy algebra. Don't let multi-concept notion scare you. Break it down by visual zones and boundaries instead. If you mapped the range correctly on your first attempt, drop a thunder in the comments below. Subscribe to Think Sharp Ali and I'll see you in question 16.